The second keynote in this session is going to be given by Jean-Luc Cambier. Jean-Luc is a program director in the Office of the Undersecretary of Defense for Research and Engineering, where he runs the Vannevar Bush Faculty Fellowship and the Laboratory University Collaboration Initiative. And he is going to tell us about DoD perspectives on fundamental research for quantum information.
Thank you. So first, I would say that I need to apologize 3 times. First is that the office director, Dr. Nair, should be talking, but she couldn't make it, so I'm a very poor substitute. Second apology is that when I was asked to go in her place, and I say, sure, and then later I start thinking about it, I do that a lot, and then I start to wonder what I should talk about, and it's really gelled only last night, so this is going to be a bit incoherent. And the third apology is that because of my lack of diligence, I was not able to get slides cleared by the Defense Department in time, so at the end I'll be just rambling on, so you'll see. Anyway. So what I'm going to talk about, first of all, I'm going to describe a little bit about what the Basic Research Office in the DoD does. I think that it's important because a lot of people don't even know that the Defense Department does basic research, and we do it a little bit differently. And I'll talk a little bit about what we do with QIS, and then the last part will be just discussion. So, in the DoD is a very big organization, as you can imagine, and basic research is split into different agents or players. And the biggest chunks go with the services, Navy, Air Force, Army, and then DARPA does its own thing. The Navy has an office that is very specific for funding basic research. It's called the ONR, Office of Naval Research. Air Force has A4SR, and Army has AARO. And then in that part there is 8% of that, which is OSD, the Office of Secretary of Defense. That's us. And so it's a small budget in comparison. The total is $2.5 billion, which is definitely smaller than NSF. And when it filters down to OSD, then it gets smaller. But I can't complain. I'm busy enough. There is only so much that I can do. So this is actually a pretty big chunk. The mission of the office. So first of all, we have to define the priorities for the Defense Department. And this is interesting because we're talking about the future priorities. Each time we have a change of leadership, the Secretary of Defense or the deputy comes to the basic research and says, how does your program match with our priorities? And the answer the directors always says is, it's an interesting question, but it's a wrong question because you should ask, well, how does the priorities 10 years ago match your priorities now? And actually, it turns out that this is a pretty good match. So whether our priorities, the Basic Research Office priorities now, will match the future one, well, time will tell, but I cross my fingers. It's probably likely that it will happen. The other thing we do is that we try to have a lot of collaborations between academia, industry, and government. We are very much concerned about the workforce. We're very much interested in that. And we are very interested in international collaborations. And these are all these themes that this audience has learned today. There is no surprise there. These are important things to work on. So all the things we do research policies. So we decide, how grants should be issued, etc. Policy is also important for different aspects, and then I'll mention that before at the end of the talk. We look at all the STEM. We have several programs for developing the workforce. We look at all the diversity programs. HBCU-MI is part of that. We have a program called DepScore, which is for disadvantaged states. We have an oversight of all the basic research that is being done inside the Department of Defense by all the services. And we have our own program at the end. And some of those, are very much liked by the academic community. For example, the Vannevar Bush Faculty Fellowship. There are some members here who have the VBFF, and they seem to like it. We have the MURI, Multidisciplinary University Research Institute Initiative. This is a collaboration between several investigators, and also this is a really nice program. So anyway, we oversee that, and we even have some international version of that program. So why does the DoD does basic research? Well, there is something called the Pasteur Quadrant. I mean, this came from a book which I never read, but the figure is easy to explain, and everybody uses it. So basically, we are in the Pasteur Quadrant. In other words, our mission is that we're looking for a mission. Whatever we do, it has to be useful to the DoD at some point. Okay. This is different from applied research, so-called Edisonian, because if you think about, Edison was looking at, finding the material that would give you the best light bulb. He didn't care why. He just wanted to find it. Pasteur got a similar problem with some crud at the end of the wine barrel. He asked the question, why? And then he discovered a lot of things that have to do with biofilms. So this was the start of a new field of science. And this is why we're interested in that. So there is also something called the Bohr Quadrant, which is basically, we don't know what it's going to be used for, but this looks cool. And we do a little bit of that too. This is just the NSF, but we do a little bit of that too. So. A big question also is how we do basic research, and we do it differently from others. And we have a lot of programs. If you look on the right, for each armed service, we have a lot of different programs, and they do things a little bit differently. And that's fine. And we have some program administered by OSD. But what is different from the other agencies is that whether it's done by the armed services or by us, is that we took a different perspective in how we select what to fund. We are a mission-oriented agency, okay, but we also fund things like inside the labs. The NSF doesn't have labs, okay, so we try to match things that are done in academia and the labs. To have this connection, we think is important. But even more importantly is the role of the program managers. Is that the typical process would be to have assemble a peer review panel, and then they look at all the proposals, make a recommendation, and then off we go. The program manager in DoD offices have a much stronger role. They define, what sort of areas they want to investigate. They build their programs by themselves after, listening to you guys. And then they think, oh, we should do this. And they can be very stubborn. They want to do this, okay? And once they do that, okay, they can get proposals. If it's their small proposal, they have full authority to fund them or not. They may decide to get it reviewed by technical experts and so on. Some of the MURIs or the Vannevar Bush, they get examined by review panels. But the program manager still has a final say. Now that's very different because that allows to push more, poke a little deeper, and take more risk. That's what we want. So the three main approaches that we have are the core grants, which is to a single investigator and university. Excuse me. And this is not a huge grant, but it lets them pursue some idea that they want to do, and that it matches basically the interest of the program manager. The middle one is the MURI, and the MURI is really interesting because it's a small team of researchers from different universities mostly, but especially from multiple disciplines. The topics are created so that we have this combination of disciplines. And this was discussed a little bit earlier, is that quantum is starting to get into the need for multiple disciplines. This is what the MURI tries to do, not only for quantum, but for all different fields. And it turns out that the size of these teams is really good for transformative science. I mean, there was a study done later that found that, these sort of small teams are good for changing things. We are not doing big science. There is a role for somebody to do big science, but we're not doing that. And then finally, we have the Vannevar Bush, which is again a signal investigator. It's 5 years, and it's really designed for somebody, who has really thought deeply about a problem and really wants to push it. It's really high risk, and we give them money and say, you're free to go, do whatever you can, do the best you can, and it works really well. All right, so QIS, Quantum Information Science, we started that a long time ago. And I mentioned that there was, we have some program managers who are very stubborn. Actually, we had a couple who had the idea that we should pursue quantum computing a long time ago, like soon after the Shor algorithm. And I show here the rate at which we provide MURIs in QIS. And you can see that the slope is changing. That means that we're putting more and more MURI out into QIS. The top part is for quantum computing and networking, bottom part is sensing. So there is an asymptotic slope because not all MURIs are QIS, but this is a pretty significant acceleration. QIS has been on our mind more and more. The other similar figure is for VBFF, which is different. It started much later, but we have a steady rate. And here these are really, top people. The separation here is on top is all about hardware, and on bottom is about theory. And it's interesting because there is not a lot of funding of theory in general. And that's, I think, something that we need to push more. The one on the right, which is colored yellow, I put it as theory or quantum algorithm, but it's actually quantum-inspired algorithm. So in other words, it's using the quantum tools to do simulation of classical problems. And I mentioned that because the problem is that it's actually looking at our high-dimensional, nonlinear equations. And there is a way to do that with quantum methods. So I want to talk about three things that I've been thinking about. One of them is diversity, freedom, and transition. Now, what I mean by diversity, first of all, there is diversity of organizations. Who is involved in doing QIS? Well, it turns out that it's everybody. Everybody. I mean, all the agencies are doing QIS, whether they do science or not. They can make agreements. The Department of State make agreements, for countries that do QIS. They're involved. Everybody's involved. So this makes a very complicated ecosystem. That's why you have this figure of this coral reef. And so there is good and bad. But it's always painful, because if you have to work across agencies, let me tell you, this is painful. Now, the good thing is that diversity is incredibly resilient, okay? It means that it's not one person that decides to go full blast into one area because you have somebody else who say, I don't agree, I'll go there. And this is very important for things like QIS because we don't actually know where we're going. Sorry to tell you that, but this is very uncertain. So I think that to have this, this very diverse funding ecosystem is really nice. Now, some people usually, when they see that, they say, well, that's bad because we could duplicate things. So what? Duplication is part of the scientific vision. It's a part of the scientific method. If somebody finds, something funded by one agency, you have to be able to duplicate it. Otherwise, you don't know what you're doing. So duplication is not a worry. But the diversity of agencies funding that is a good thing. The problem is that this requires a lot of talk between agencies and their people. And that is a difficult part. Not because people don't want to, but because the mechanics can be time-consuming, can be difficult, etc. So that's a hard part, and that's what requires a lot of effort. And this is a really good place to do some of it. The other diversity is that this is everybody's involved as far as government, industry, and academia. It's a big melting pot, especially academia and industry. I mean, everybody doing QIS and their third-degree cousin are creating a startup. So this is complicated, okay? And how these two merge with each other is something that can be a bit uncomfortable and that we should maybe think about. So there is a diversity of approaches. As I say, we have different funding styles, NSF, us. It's good. And that means also that we should not rush towards the same things. It's good to keep a balance. It may be that some area is really promising at this time, but let's keep the other one at least on the back burner to see where it goes. So that's all a problem, basically, of trying to find what is the optimal ecology of all that. I don't think there is any good answer, but I think that we should think about it, about, do we have an idea of where we're going and how we do this, or we just let it happen? And I think that we should think about that to find out what is missing, what are the gaps, how do we do it better? And that's what actually my job is, really, is to hear from you what are the problems, because on the ground level, everybody wants to collaborate. Everyone wants to push things. But there are roadblocks. And our office is there to smooth out these roadblocks. So whatever you say, whatever you discuss with each other is important to us because we need to hear. And the other thing, too, is that we should allow contrarian viewpoints. My job, I am not a QIS advocate. I am an advocate for everything. And that means that there are some people who may think that QIS, well, okay, quantum computing is not going to give you the big benefit that you want. Okay, fine. Maybe you're right. Maybe optical computing can do what QoS can do. Let's find out. I want to find out. So don't dismiss the opposite side, because what you are being judged upon when you do QoS is really the classical world, which is a moving target. You know very well that you develop, people have developed an algorithm, quantum algorithm that can solve that. 2 months later, somebody has a paper that says, I can do it classically. Okay, there is always a scale of a problem where a QoS will win. But what is that scale? I mean, you have to pay attention to what the comparison is, because that is moving really fast. Finally, diversity means diversity of people. And you heard about that, the fact that we are missing a huge segment of academia in the country in doing QIS. Okay. And academia, I mean, students, starting from K-12, etc., all over the country. And that's something that we're also very concerned about. Among this, as part of this issue of diversity of people is international collaboration. We want more collaboration. We want more people from the rest of the world to work with us, to come here from anywhere and work on basic research. We all gain from it. So I hope my message is clear. Along with that is freedom. What do we want? Freedom of thought. You must have a broad spectrum of ideas. Don't hesitate to come to us with an idea that you may think, well, will not be accepted. You don't know that. There are some weird things that I read, and sometimes there are some part of that, something that is, I never thought of that. This is interesting. Don't assume that ideas that you have will be rejected. We're looking for new ideas. And that includes antagonistic ideas, classical computing. But the thing is that, remember that basic research is defined by, by the government through a memo by President Reagan that the government cannot control who is doing basic research and the government cannot prevent you from publishing. So we are full open science. And freedom of movement. We want people to come from all over the place. Transition. First of all, is a question of what is useful. I'm very curious about that because there is talk about building a system with million qubits. 2 to the 1 million is one huge Hilbert space. What is it going to be used for? I'm curious. Do we need that much? I don't think so. And think asymptotically. Again, I'm a physicist. I always think asymptotically. You have an infinite computer, infinite size, infinitely fast. How many computers do you need? 1. It solves the problem immediately. So it will be infinitely costly because there is only 1 computer. But there is something in between that we need to find the sweet spot for QIS, for quantum computing. And it's very varied. And I think that I like what I hear, here because there are so many ideas about where this is being applied. And again, this is a moving target. The classical world is catching up, but this is where you have to think about, where is this going to be useful? Because we need the roadmap. Otherwise, somebody with an opinion and no knowledge will tell us what the roadmap is. So what you're doing is very important to us. And I'll stop here.
All right, thanks for a great talk. Have we got a few questions for Jean-Luc?
So there's been, in the last few years, quite a few news articles about the government's interest in placing more export controls on quantum technologies and how this would impact the freedom, as you noted, and work in companies and startups. Do you have any comments or thoughts about would that also impact academic research?
The government is a big place, and there are some aspects, some parts of it that would say something like that, and there are others that don't agree with it. So there is always this tension. I would say that as far as academic research, it will be very protected. Now, I must say that you have to use common sense also, is that you cannot be naive, but you should not be paranoid. Does that answer your question?
Thank you.
So you said you encourage people to don't only submit ideas that fall within some established research track. Send us more out there ideas. But a proposal is many pages. It often has a deadline. You wait 8 months to hear back, or it depends, and that's a lot of effort being put into this idea that you expect is going to get shot down with a 90-something% probability. Are there channels? Are there ways to make that sort of better, ways to get feedback on initial ideas, ways to to make that work in practice?
I'm glad you asked this question, because this is why we're doing things differently, because a lot of times researchers can just send an email to the program manager, a few lines that say, this is what I'm interested in. I can send you like an abstract. And then if you're interested, I can send you a white paper, and you can start the discussion. And don't be discouraged if that program manager says, well, I'm not interested. There may be another one. If you have problems finding program managers, let me know.
This is kind of technical, but do you consider quantum foundations, do you put quantum foundation research in the same bucket as quantum algorithms, or are they different subfields in quantum information science to you? When it comes to funding research, like quantum foundations?
So I'm not sure I understand the question. You wonder if quantum algorithms are the same thing as?
When it comes to funding research, do you consider quantum foundations to be a different field?
Yeah, I mean things like non-contextuality and or things like that. Yeah, these are really interesting things. Yeah, why not? To give you an idea that once I am guilty of having co-promoted a MURI topic on quantum information and black hole physics. So anything goes.
So thank you for the nice talk. I was curious, for some of these single PI grants, are these restricted just to government labs and academia, or do you also hand out grant money to companies to develop technology?
So we mostly fund academia. We have special programs for the DoD labs, and we have programs for collaboration between the two. As far as businesses go, we don't have the same flexibility as DARPA. And we would fund programs through the SBIR, STTR program, small businesses. We had a program in the past where we fund a pilot program. We love to make pilot programs to see if that works or not. Where we had a pilot program where we fund a collaboration between academia and any business, including big business. One of them was Boeing, and another one was Northrop Grumman. And we stopped that, but I thought this was, a relatively good program. But most of the innovation lies in the small businesses, so that's where the SBIR STTR program is. Now, we did start our own STTR program, not a lot of topics, but I think that we'll continue that. But that basically, to answer your question, that would be the main mechanism.
Thank you.
Let's thank Jean-Luc again.
Thank you.